Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about the energy losses in our concentrating collector. In previous classes, we have seen the types of concentrating collectors. Okay. In today's class, we will see the losses which happened in that types of concentrating collector or in the concentrating collectors. Okay. Now the concentrating collectors, there are various sources which cause the losses of solar radiation. Okay, and these are the source as the incomplete reflection on the mirror surface. Okay, incomplete reflection of the mirror surface. The mirror which we used as a concentrator in our concentrating collector, the that mirror have if that mirror have uh, default reflection index or incomplete reflection happened, then the radiation, the solar radiation didn't focused on the what observer, so losses happen or losses is there. Then second one is optical error in the mirror surface because of the limitation of fabrication techniques. Okay, that is when that mirror is made in the factory or industry, due to the limitation of the fabrication. Okay, there is an optical error. Optical means the focal length or the reflective index, that is okay. And third one is orientation error, as the mirror may not be exactly oriented along the solar axis, or the observer is not exactly in the focal point or the line of mirror. That is, in if the antenna is not the parabolic antenna always what faced towards the axis of the sun. Okay, but if it is not facing the sun axis exactly, then there is a disorientation of solar radiation, so there is some losses are there. Okay, and a reflection on the absorbing surface. That means the which rod is absorbed the solar radiation. If there is solar radiation, that have also some reflex, that have also some reflection, so that due to that reflection some energy will losses. Okay, radiation from, and the fifth one is radiation from the observer in the long wave range, and the radiation and the which the observer which reflects from observer which radiation is reflected, for that reflected radiation uh, there is some energy losses. Okay, and the sixth one is convection from the observer. That means convection, or the heat is convect towards the earth or towards the atmosphere from the observer. That's why some losses are there, and now we'll discuss them briefly. Okay, first one is incomplete reflection of the mirror surface. That means, depending on the material, the various reflector available for solar energy use have a reflective of 0.76 to 0.93. Okay, this means that 7 to 24% of the incident radiation is not reflected to the observer. The energy loss due to the incomplete reflection can be this much. That means uh, various material or reflector is used in the parabolic or the all the concentrating collector. That material have the reflective that material have a reflective from 0.76 to 0.93, this much. Okay, so the rest 7 to 24% of the incident radiation is lost due to the incomplete reflection. Okay, and that energy loss is equal to the QR equal to 1 minus rho whole into IDV AR. Okay, we here rho is reflectivity of the mirror. IDV is direct radiation on a inclined mirror. Okay, inclined mirror surface, and AR is a aperture area of the mirror. Okay, next one is inaccurate inaccurate inaccuracies in the mirror surface. Okay, the mirror surface is very often not exactly shaped and not and has corrugation. Okay, which is not visible in our naked. That means the mirror which is made for the reflector or concentrator, that have not exactly shaped. Okay, and has corrugation, that is has deflection uh, or get damaged. Okay, which is not visible by the naked eye. They are also some deviation from exact geometry counter. That means exact geometry, that is what is the focal point of that mirror or concentrator, that is not uh, occupied or exactly occupied by the manufacturing. Okay, so that some energy, some radiation is losses or didn't incident on the observer. Okay, then third one is tracking inaccuracy. That means if the orientation is not good of the collector. Okay, because in concentrating collector, the concentrating collector is or should be in the along the axis of the sun always. Okay, but if that if the tracking process is not good, then the orientation of the antenna or the orientation of the collector is not in the along of the sun axis. Okay, so that some what some radiation is losses or didn't incident on the collector, so that some losses are there. Okay, and fourth one is reflectivity or emittivity of the observer. That means here in the concentrating collector, the temperature goes to maximum value of 500 degrees Celsius, and the observer also coated with a reflective or a selective coating. Okay, and not only the high temperature, but also the considerate UV radiation makes the working condition of the sensitive selective surface more difficult. That is due to the high temperature, and also due to the UV radiation present in our sun radiation, the working condition of the solar collector or concentrating collector is much more difficult, and that's due to that heat or UV radiation, there is some losses are there. Okay, that losses is for reflectivity or emittivity of the observer. Okay, next is convection from the observer. That means The absorber always, or the absorber absorb the heat and get hotted. Then the surrounding of that absorber, the surrounding air of that absorber is not so not so heated. That means the absorber is heated or hot, but the surrounding is cool. So the heat from the absorber transfer to the surrounding, and due to this heat transfer or heat loss is called convection process. Okay, and due to this convection process, some heat also be lost. Okay, thank you.